Before starting the class, I really need to, say sorry to you because I cannot have next Tuesday, Wednesday class because I need to go to Fukushima. You guys know wreck power plant. Yeah, I'm one of the investigator of the IAEA. So I really don't know if I can be exposed to the nuclear skill today. So I think I need to make up a class. Could you please first so what do you think I'm having Monday evening class? Is it okay to you? No? Okay to me. Huh? It's at least you have class. Okay, so well I think I should ask you to take the student representative. Unfortunately, nobody actually taught, and so right now I really need a student representative. Or actually, these two nice female students actually raise their hand. The problem is they are not civil and environmental engineering students. I'm not talking, civil and environmental engineering student should do. But mostly here, civil and environmental engineering students. So this is just kind of server for student. So I really want anybody volunteer this work. All right. So please drop by my office. Who want to be a volunteer this fall? Maybe this afternoon or this evening. Okay. I will give you 10 points. Is it okay to you? Yeah. The full credit is 1,000. That means 100, 1 point per 1%. I will give you 1%. Happy. All right. So I really want to have makeup class on Monday, or actually I need to go to Japan Tuesday, Wednesday, and Thursday. So I cannot have. Definitely, we will have Monday, regular class, and I need to have makeup class evening time, or if you really hate this though, we can have early morning class actually, maybe 7 o'clock or something like that. We can do 5 or 6. So you guys can choose which way you guys want to go, right? And I cannot have Wednesday class, and we actually have Friday. We will have Friday, but unfortunately, I do not say, fortunately, there is one very famous environmental engineering professor from University of Wisconsin. His name is Professor Jaegang Park. He is very famous, world-renowned environmental engineering professor at the Department of Civil and Environmental Engineering in the University of Wisconsin. So he will drop by KAIST, our department, Civil Engineering Department, and want to give a talk to us. I can say, unfortunately, he has not much time. He needs to talk around the 11 to 12 this hour actually. So I think I'm maybe a civil engineering student representative will talk to you. It will be maybe
the big bloom at the first there's near the chemical engineering. You guys know that, right? So most of the civil and environmental engineering students there, and well, your presence will be checked. So that is very, very important. And as I already told, he is very world-renowned environmental engineering professor. So I think this is good time for you. Maybe who want to have environmental engineering, major, right? So don't forget that, and don't ask me, Again, I think I just told you several times. You guys just send email, Is this right? Yeah, this is right. Right? Got that? Good. So, student representative. I can give you 1 or 2 points for 100. So please be a volunteer. All right? I think just server. Yeah. Well, you guys can together and then choose what time is good for you for the makeup class. That is one of the service the student representative should do. Right? In this kind of role of bridge between student and professor. All right. Last class, we have talked about some basics of chemistry. Well, this guy, he's very nice scientist. And also, we have talked about the atmospheric structure, troposphere, and stratosphere. There are mesosphere and thermosphere, but our concern focuses on the troposphere and stratosphere. And also, there are 3 and total 6 reasons for air circulation. This is very important for the mixing of contaminants or long-range transport of contaminants between the equatorial to the polar area. All right. Then we actually need to talk about the ozone, because ozone can cause very significant impact on the environmental problems. Well, as I already talked, we are talking about stratospheric ozone, which is very good guy. Well, as I already talked, ozone is blue gas, and also it has electric and fresh-ish odor, and also very reactive. The structure, ozone atom, 3 atom, with the bonding angle is 127 degrees. Ozone actually absorb, the absorption occurred inside, which means ab. AB absorption is the absorption occurred on the surface, right? This is B. So ozone actually absorb UV light in the range of 200 to 300. So here the concentration is around 10 ppm. Ozone just acts as Earth's UV shield. This is just kind of UV sun screen cream. So if the ozone layer is destroyed, well, you don't have to. Well, actually, you just dig out the ground and go to the ground. That is what you should do for your survival, actually, right? So ozone actually prevents the light wavelengths less than 300 nanometer for reaching Earth's surface. So, well, here, if you lost ozone sunscreen, we may have more skin cancer, and also eye cataracts. What is eye cataracts?
some kind of serious pain problem. But this is not that important. Cancer problem is most serious one. And also, there is a kind of decrease in photosynthesis. Well, as I already found, you need to dig out the ground and difficult to the ground. And also, lower temperature could jerk from ozone depletion too. All right, and then, well, how ozone can be degraded? Well, we actually, very care about the ozone depletion or ozone degradation on the stratosphere. Most of you know maybe CFC and other chemical compounds can cause or accelerate the depletion of ozone in the stratosphere, right? But naturally, ozone can be degraded by this simple Chapman reaction. At the stratosphere, oxygen actually reacts with UV, ultra. The wavelength is around less than 240 nanometer. So the oxygen molecule can be degraded to oxygen atom. This one oxygen atom can react with one oxygen molecule with the catalyst. This is just the third body, acts as the surface catalyst, catalytic surface. Then it can produce ozone. Then, because this is kind of catalyst, here is M star. It could be nitrogen or oxygen. Then ozone, the produced ozone can react with ultra UV. Then it can be degraded to oxygen molecule and also oxygen atom. So the total equation can be summarized by the ozone molecule react with oxygen atom, and we can produce 2 more of oxygen molecule. So in the long run, the ozone can be degraded naturally in the stratosphere. So ozone degradation and formation, occur simultaneously. So this is natural degradation of ozone. So this is from the old days when the plankton start to live, and also the dinosaurs actually live. At that time, ozone also degraded naturally at the stratosphere. The problem is, this is degradation, formation. Well, the process is kind of there is sink and there is production, so we don't have to worry about that. But here, I'd like to give some more explanation here. The net result of this equation, the chemical equation, is like this, and there is the release of heat because UV actually vibrate the air, and it can be released. So this is the reason why this stratosphere is warmer than troposphere. The temperature can be increased, right? So this is the reason. And also, stratosphere is the only reason. Earth is atmosphere only the reason. Well, there is both UV radiation and gas pressure. So this kind of reaction, serial reaction, and simultaneous reaction can be occurred, so that the molecules and atoms can fly. So the Chapman reaction, ozone degradation reaction, natural reaction, can be accounted for 50% of the ozone reaction in the stratosphere. All right, but what is the problem? why we care? If this is just, natural degradation, why we care about the ozone depletion in stratosphere? You guys may heard about there is very big hole in the Antarctic area. Is there any big hole in the Arctic area? Have you heard about that? It is just like is there any polar bear in Antarctic area? No, right? Penguin in Antarctic area and polar bear in the Arctic area. So ozone hole in the Antarctic area, there is no ozone hole in the Arctic area. Is it right? Yeah, that is right. The problem is nowadays, you guys can find the big ozone hole in equatorial. Wow. How is it possible? How can you guys detect the big ozone hole?
Measure the concentration of UV.
Yeah, well, that is kind of indirect method to show the big ozone hole. How can you take the picture of the ozone hole in the sky? Soviet Union and United States, what they did around the 1960s. Satellites. The satellites can, take the image of ozone hole using UV special camera. Well, I will show you later. Anyway, the ozone hole actually, found. Is it natural, phenomena? If not, why we are so care about that? So some, environmental scientists and chemists start to care about that. So here, the chemist and the environmental scientists start to think about some potential possible ozone depletion chemical reaction. So they can actually assume this simple catalytic ozone depletion reaction. Here, ozone reacts with some kind of catalyst, X, and then it can produce XO and one more of the oxygen molecule. The XO actually react with one oxygen atom, then it can produce one more of the oxygen molecule, and X just released. So here, actually XO didn't change anymore. So this can be, we can call it catalyst, right? And the net reaction is ozone actually react with oxygen atom and then produce two more of oxygen, right? So here, X can be catalyst. So if so, what kind of catalyst can be used for this ozone depletion in the stratosphere? So this is very, very interesting. So this is just like, if you are a very famous scientist, well, most important thing is which kind of event you want to find out is very, very important. If you are a journalist, you are at the, some specific reason, you really want to, find very big issue. If you can find very big issue, you can be a very famous journalist. If not, you cannot be, famous. The important thing is, the scientist, who has, significant level, this kind of issue finding is very, very important, right? So, the scientists actually provided some catalyst pairs here, and we call this catalytic cycle here NO and N2O. NO, nitric oxide, well, we call it nitrogen monoxide, and NO2, nitrogen dioxide. This is one pair for the one catalytic cycle to degrade ozone at the stratosphere. And then the next catalyst pair is OH. What is OH? Hydroxyl radical. And what is OOH? You can speak aloud. Carboxyl. You need to have the C, right? In this case, we call it hydroperoxyl. Hydroperoxyl radical. Hydroperoxyl. What is Cl? Correct. And what is OCl?
Mesh.
Well, that's correct. Correct. Is this good correct? We call it hypo, 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 chlorite, hypochlorite. So they just proposed this, catalytic pair. But the important thing is, what is the source of this catalyst? Well, for the NO, there is two possible potential sources. Well, actually, NO can be originated from nitrous oxide. Nitrous oxide is very significant gas. Is this global warming gas? Yes, it is. The amount is very small compared to methane and CO2. Why is this so significant and important?
So laughing gas?
Yeah, right. And also, if you have very, serious toothache, if you smell this, well, your pain is a little bit relieved. So all days, the dentist used this one, painkiller, actually. The problem of this nitrous oxide is this amount is very small, but it has 300 times more powerful than CO2. Right? Small amount, but it can have 300 times more power for the greenhouse effect. So this is the reason why we care about the nitrous oxide. So nitrous oxide can be, originated from nature, from swamp, And so nitrous oxide react with the oxygen, atmosphere oxygen atom actually, and it can produce 2 more of nitric oxide. And also, this is a little bit, very, rare case. This is combustion from supersonic airplane. Think about the Concorde. I think a Concorde is just a paid out, but nowadays France started to, Concorde business again. Right. So the Concorde actually, the supersonic airplane, but the pure, and there is kind of nitrogen and oxygen in oxidation, and it can produce nitric oxide. So here, nitric oxide at the stratosphere produced by Concorde or this gas from the swamp, and it can react with ozone, and you can have nitrogen dioxide and overall oxygen molecule. And this nitrogen oxide react with the ozone oxygen atom and produce oxygen molecule and NO. So NO, these two, and also NO2 can be used as catalyst here, right? And the net reaction is ozone actually degraded to oxygen molecule, right? And then the second scenario is hydroxyl and hydroperoxyl radical. Well, methane. Well, can you get the methane easily? Everywhere from nature, right? The swamp and the cow, and from you when you civilly play football or something. And this methane react with oxygen atom and produce hydroxyl radical and the alkyl radical here. And the water actually also is the main source of the hydroxyl radical. It can react with UV and produce H and OH minus. OH. This is not hydroxide. We are talking about the hydroxyl radical. Totally different. As I already taught, Cl and Cl2 and Cl minus is totally different. This can kill the people, and this cannot. Well, this, NaCl and salt water, if you drink the seawater, you cannot get killed. But if you dissolve this chlorine gas in the water and drink it, you can get killed. This is totally different, right? This hydroxyl radical react with ozone molecule and produce hydroperoxyl radical and oxygen, and hydroperoxyl radical react with oxygen atom and produce hydroxyl radical and oxygen molecule. In the long run, you can have ozone degradation here, the same thing. But hydroxyl radical, hydroperoxyl radical, play a role of catalyst here, right? And there is some very significant. Well, in Korea, if there are people list, the person is very, very significant one, right? But in the westernized country, the most significant person actually appear at the last. Is it right? Is it? In France, if there is three, people here, and the most significant person appear at the last. No? It depends. Yeah. Well, makes sense. Carry on. Okay. Here, this is very significant catalytic cycle using chloride and hypochlorite. Cl actually react with ozone and produce CrO and oxygen molecule. CrO react with oxygen atom and produce Cl and oxygen molecule. In the long run, you have the same reaction here. So why we are so freaking out about this? Because there is from the photodegradation of CFC. Have you guys heard about the CFC? This is widely used refrigerant. Very well widely used refrigerant. All days refrigerant was ammonia and SO2, sulfur dioxide, which are very toxic. Even it can be exploded. In 1940, Texas, there is very big, explosion of this refrigerant loom. So around 1,000 people get killed. So these are very toxic and reactive. Actually, in 1935, Japan actually invented Freon 11 and Freon 12. This is very unreactive. If you just breathe the freon gas, and actually you can breathe it with nose and you can exhale in your mouth. So it cannot be easily dissolved in your skin. Very stable, right? So the DuPont actually very rich, chemical, company, right? And what is the next popular chemicals DuPont made? Yeah, Teflon. That is very good. Teflon is kind of, I can bet, Teflon also cause very serious, health problem. Well, US, I really don't know, you international student, most of the Korean here, they are using, kind of automatic, rice cooker actually. If you can see that, well, if your mom actually purchased it at the first day, you can see very dark coating of the Teflon. But if you use it maybe 1 or 2 years, you can see very light color of the metal. That means you are eating Teflon every day. But as a laptop, Teflon is very, very stable, just like Freon. Think about that. The frying pan is actually coated with Freon, Teflon. We call it PTFE for, let's see, hold on a second. Anyway, if you just hit it around the 700 Celsius degree, the Teflon cannot be burned out. It is stable. So that is the reason why you have very nice egg pie. Yeah, right? The problem is the Teflon is very weak at the physical attack. So if you just use the metal spoon and do it, and you can just remove the Teflon coating easily. The important thing is you're eating Teflon. As I read, the Teflon, well, it can be easily removed from your body. Even the polar bear, if you just take a polar bear's blood, you can find Teflon. So the polar bear using Korean rice cooker, they are cooking rice, and then they are using their, they consume the Teflon. No, nobody think of, assume that. Maybe we just have assumption the Teflon, DuPont actually made it, and the Teflon can be long-range transported from the somewhere in the United States or somewhere in the region which can be which was produced, and then it was going down into the polar sea and the fish and the plankton, and finally polar bear actually ate the fishes. In their blood, you can find Teflon. But the problem is we don't know. Well, I really don't know. Maybe the writer of the book, the text, Ron, really have very significant interest in the Teflon because he believed Teflon can cause cancer. But problem is, well, as she said, it depends. Although some, the smoking, cigarette smoking is very bad, right? But at some place at the Kazakhstan or somewhere, well, you can find 100 or 120 years old man. He usually smoke. So can you say for them? Can you say cigarette smoking can cause you, significant lung cancer? Maybe you can be died of, lung cancer, but the So it depends actually. But DuPont really have very good scientists. Maybe half of the environmental scientists actually have a job at DuPont. They depend actually the harm side of their chemicals actually. They also hire lawyers. So I just want to ask you, what part do you want to stay? Do you want to stay at the DuPont side and depend the chemical, the economics of the chemical, or you can be I cannot say the light side, because it depends on your conscience or your, So, well, anyway, this is very, very important. All right, I a little bit digress from the topic. Well, anyway, the production of this compound is 10 to 9 kilogram per year. Wow, that's too much, right? So think about that, how much money DuPont actually can earn using this stable material. this compound made an important domestic name as a refrigerant. They were non-toxic and non-flammable. As I already talked, if you breathe freon, you can exhale freon to your mouth. Stable, and actually they don't have any no sink. Sink means degradation in the troposphere, so it cannot be easily removed in the troposphere. As I already talked, you guys think well, actually, you guys are very tough and strong because the environment of the Earth is very, very, tough. You are surviving right now, right? But if you just take out the some microorganism, let's say Ebola virus, or let's say AIDS virus, if you just put it from the container, preventive container, and then take the virus outside the container, it can get killed. Well, actually, virus cannot be killed, but it just go to the inner state. Virus can live in good, environment, and bad environment, they are not. They just stay as inner. So that means this environment is very, very, tough. How? It's very cold, and also there are many chemicals, very, very strong oxidants, just like hydroxyl and ozone and nitrate. It actually attack your skin and your lung system. You know that. So you guys are very, very, strong, animal actually. I really mean that. Yeah. So, but the important thing is, this freon is too tough. It cannot be easily degraded by the hydroxyl, by anything. It cannot be destroyed in the troposphere. So, the residence time of this chemical is the order of 100 years. That means they cannot be removed. It just stays. So this is the problem. So this freon Cl, continuously provide Cl to the stratosphere. So the catalytic cycle can be continued to destroy ozone. Right? So this is the reason why the people, the scientists, and all the people on the Earth are so freaked out. In 1974, Roland and Molina suggested the only environmental sink, the degradation source of these CFC compounds was the transfer into the stratosphere. So the one way to remove this freon is just transfer it to the stratosphere. That's it. Then, the important thing is these two, plus one more guy, won the Nobel Prize in chemistry. Wow. And this is very simple equation, but this equation can give them Nobel Prize. Right? Here, you can see the freon and react with oxygen atom and the CO2, and there is Cl2 actually produced. Cl2 can react with UV, and it can produce 2Cl. And also, out of freon here, CCl2 actually react with UV, and one atom of Cl can be produced. All of these chloride and hypochlorite chloride can be actually used for this catalytic cycle to degrade ozone. The atmospheric concentration of CFC actually increasing rapidly. 1971, it was 50 ppt. How do you measure this concentration, by the way? How do you measure it? Any guess?
라디오던데.
Radio.
라디오던데.
Huh?
라디오던데. By balloon.
Yeah. Well, in 1970s, they are using the balloon, but the problem is you cannot get, it easily. It just disappeared. And 1970, I don't think remote, gears are very, good at that time. So the measurement is not that good. But nowadays, they are using airplane. So the airplane actually fly through the stratosphere, then take a sample, air sample, and it can be automatically measured by gas chromatography and also any other spectroscopy, mass spectrometry, and they can measure the concentration. NASA usually doing this. And then the concentration actually increased. 1990, it was 380-50. So mid-70, as I already told, everybody was concerned about the effect of CFC on ozone, but it was not convinced actually. So the scientists actually know, CFC is not good for the ozone pollution. Maybe the scientists know there is ET, on the Earth actually. We care about that, right? But someday, maybe your son or your grandkids can know if there's ET on the Earth. And 1978, the non-essential uses were restricted. Maybe the aerosol propellant, just like the F killer in Korea. I really don't know what was that, but it was CFC at the time. And the hairspray, actually CFC was used. However, 1985, the depletion of ozone was certain because the Antarctic ozone hole was found. This is very nice, shots of the ozone. Okay, you can see very blue sky, and then there is ozone, but as time goes by, you can see the blue, hole, great hole here, right? Anyway, 1985, actually, the ozone hole found, so everybody freaked out, and the Antarctic hole grows each winter. As you said, the concentration of ozone actually at the stratosphere actually decreased. It is very serious problem actually. So the Antarctic hole grows each winter. Maybe Antarctic area obviously is the winter time, and then collapse each spring. Each year the ozone depletion was get worse actually. So now, I just want to ask you, why there is no polar bear at the Antarctic area? Why they're just a penguin? And yes?
Because the rain cannot swim around the sea.
Mm-hmm.
And
Can you fly?
Initially, it's still fine. But after a long time, people lose it.
Right. All days penguin can fly to the Antarctic area, and the temperature just going down. So they adjust themselves. But well, they actually don't have, they don't have their wings actually, right, at the Antarctic area. Well, that's possible. But my guess is there's no Coca-Cola in the store at the Antarctic area. Yeah. So the polar bear actually enjoy Coca-Cola. All right. I think this is it for today. We will talk about why the Antarctic area specifically we can find the orbital. All right. Any questions or any comments? Okay. Thank you very much. Have a great day. Great talk.